All right, hello everyone. Welcome to our last class. We're going to talk today about a lot of the things we've done previously, and then add to that by talking about how to export files from Rhino to useful applications. And most of what I use it for is creating Rhino files for fabrication, for illustration, for rendering, and then less so for virtual reality and gaming, but you could do that if you wanted. So the first thing about exporting is to know some file types. Rhino files are .3dm and Grasshopper files are .gh, which we've used already. I guess we could divide files into ones associated with software that are private and ones that are kind of a bit more open. Generally, compatibility with lots of softwares is like .dxf, which is more of the open file created by AutoCAD, is going to be a lot more compatible with smaller softwares and able to get files around easier than some of the more private files. Then some of the file types are sort of updates or upgrades that increase the capability of certain types of files. So a .step file, .stp, is a sort of successor of a IGES file, IGES. And some of these have some interesting histories. IGES files go back to the US military, and object files are like .stl files, but they allow materials and textures and things like that. So .stl files is the main 3D printing file that does not allow textures and color, and then the successor is the .amf, which is the additive manufacturing file. But generally with file types, if I'm going between different softwares, I just like to trial and error, see if it works. Sometimes the geometry doesn't go through on a certain file type, and then just try a different file type, and it probably will work. In the Pepakura example that I'll show you guys later, that I went through on a few file types and it didn't work, and then .stl worked. So sometimes it's just whatever works. So when we're looking at file types, they're going to transfer different types of information and not transfer others. So the questions are, can it store NURBS curves? Can it store NURBS surfaces? Can it store poly surfaces? Can it store meshes, subdivisions? Does it have textures, materials, lights, animation, rigging, object properties, groups, layers, low file size? So for Rhino files, that animation and rigging is not really a Rhino thing. That's more of a sort of Maya or 3D Max thing. So that won't save from the other softwares and come into Rhino. If we look at Illustrator, at least the way I use Illustrator, that it's mainly just for putting curves across, that you don't really bring full 3D models into Illustrator. And luckily, groups and layers stay intact when moving to a .ai file. And if they didn't, that would be really problematic, as I'll show you on some examples later. So to start, back to this building, Casa da Música, in Porto, in Portugal. And I created a 3D model of that building. And I want to just mention that if we look at this 3D model in any of the 2D views, it's still 3D geometry, that if I click on any of those points to snap to them, they're very much three-dimensional. They are not on the same plane, but sometimes I want to export a two-dimensional drawing. So make 2D is a very, very useful command. And when looking at any view, it will project what I see to a two-dimensional curved drawing. Sometimes these curves are grouped in strange ways, so they sometimes need some editing, but make 2D is how I go from a 3D model to just say, give me the two-dimensional projection of that. And it always sort of ends up at the origin point 0, 0, 0. So that there's my two-dimensional front view. That's sort of the 3D model. And then if I make 2D, now I have a two-dimensional projection of that. That's curves. And I can save that as a .aa file and export that to Illustrator or somewhere else. And then in Illustrator, I can do stroke widths a lot better and start coloring it in. And I like Illustrator models with 0 stroke width with the colors filled in. So that's just me with a a fill command, just filling each color manually. That's not a render. And there's a three-dimensional model. So Make 2D is great for diagrams. Here's an example of Gary Ingalls, and they want to propose a big space that goes on the roof. So each one of these would have been drawn in Rhino, possibly on different layers. And then that's the proposal to take over the rooftops of this famous shopping store called Magazine. And then here's another example that I did for a t-shirt where you can do any font in Rhino, drag in custom fonts. So this is a Rubik from Google Fonts collection. And if you explode a font, it turns to curves, so that now they're just NURBS curves. And then I just extruded those curves, drew some roads between, and messed around with the camera settings that I'm going to talk about later to sort of create this perspective view with a wide angle lens. And then that was brought into Illustrator, did some fill on the top, and then that was ready to go for a t-shirt, which was my local running club when I lived in New York City. So another fantastic software is Pepakura. It's less than $40 to buy, and you can drag any 3D model from Rhino. And I used a .stl file, which wouldn't transfer over textures, but it just unfolds the geometry and gives you a very precise thing to cut with flaps, so that you can cut it out and assemble it as a sort of paper model. These lines, if you bring them into laser cutting, are really, really accurate, and you can make very, very precise models by taking your 3D geometry into Pepakura, then bringing it to a laser cutter afterwards. So this is textures on top to create this dice. It's one of their preloaded files. So I did the Casa de Musica model, did the unfold, that's what it would look like in Pepakura, did the unfold, and this is the geometry here. And that would be great for laser cutting. And I'm just going to get out of this PDF and to show you in Pepakura. So this is their animation showing how this 3D would unfold. You can see it kind of unfolding. Now back to the PDF. And I've seen some people use very, very detailed Grasshopper models with the most intricate parts, bring it into Pepakura, and then laser cut them and have these really, really precise models that would be impossible just to figure out the unfolding patterns otherwise. And you can kind of drag and drop if you want a different unfolding pattern. It just sort of moves across the page. So Wintercroft is a company that makes different animals as masks. You can download them for a couple $dollars each. But if you wanted to make your own, you would make the 3D model and then use Pepakura to make the unfolding pattern of these kind of masks. So this is a standing desk I designed, and this is a Make 2D on the side view and a sort of perspective view. And there's Make 2D colored in from Illustrator. And I kind of went back and forth using a nesting software to make the most efficient standing desk I could possibly think of. So I wanted 2 of these to a 8-foot by 4-foot sheet. And this is an example of what Rhino Nest, which is a quite pricey plugin for Rhino. It's about $1,000. But there are open nests that I haven't tried, but I might try soon as a free alternative. And you can kind of see that you select any curves that you have drawn that can be anywhere in the model, and you first set your stock size. So I'd set it to a 8-foot by 4-foot or 2440 by 1220 millimeters. And then in millimeters, because I did in millimeters, distance item to item. So it's going to do that. Distance item to sheet, that's the border on the edge in case I've got some screws or some hold down to hold that material down, but I don't want the router bit to go anywhere near the screw because that would damage the router. freedom. Do I want the curves that are going to be put into this nest to stay their orientation, or they can rotate 180 degrees, or they can be free and rotate any direction. And some of these nesting criterions to minimize X, because you might use the rest of the sheet, and you can kind of do different settings on nesting. So this is the desk. This is the shorter desk, which is 3 desks to the sheet. And you probably know the famous story of the chess player Kasparov, who lost to Big Blue, the computer by IBM. And a couple years later, that they did the experiment again, but allowed the computer to play against the computer and human beings. I think they call that a centaur, and the centaurs won. So the humans do what they do best, the computers do what they do best, and as a team, they beat computers pretty easily. So with nesting, there's sort of sometimes a mix of human and automated process. For this, I kind of changed the design to sort of maximize the desk size based on filling the void of this sheet. So I get 3 desks to the sheet, and then this is the bigger desk with the top piece, 2 desks to the sheet. And then for CNC files or laser cut files, that a lot of the time you're just dealing, at least from a Rhino perspective, as flat 2D curves. So this is a bear shape, and I have them as different colors, so that when I export them, they will, the different colors represent different layers, and when I export them, they'll be on different layers. And I just, for the CNC file, want to say that this inner blue line, I'm going to pocket cut on the inside, which means I'm going to cut all the material in the middle. And you set a height for that on the machining. So I set 2/3 of the stock, the 18 millimeters. And then next up, cut on the outside of this red line, and cut again 1/3 into the material. And then afterwards, cut on the, pocket cut this green area, and then cut on the outside of the red line, which is a profile cut, which is going to cut out the shape. And you always kind of leave to cut the material loose from the bigger sheet as the last step, so that the material doesn't move around. And then this was the other side of my little bear shape, which cut on the outside of the profile cut and pocket cut this whole interior 2/3 down the material. And this is what it made. This was a sort of, I wanted a place to put my cufflinks into this as my wedding favors, since my wedding reception was in a zoo. And there's sort of a zoomed in thing of this bottom part, and the top part just snap friction fitted on to have this little cute storage space inside. And I made lots of different animals, mainly because my wife asked me to do small animals first, made 100 of them. And then she's like, no, I prefer big animals. So then I made another tons, we'll get tons left over. And this is where nesting comes into really useful. So they're all on different layers, which if I had to manually select those curves in a CAM software, which in my opinion is not the most user-friendly, it would take forever and I'd probably make 1,000 errors. Where as long as they're on different layers, I'm saying pocket cut the purple layer, do the profile cut 2/3 the way down the sheet on the red layer, and so on. And then these shapes are obviously rotated because I allowed them to be free rather than fixed on the nesting settings. And I set a rather wide distance item to item, and a distance on the edge, so that I've hold down screws on the edge. And there's an example of the carcass left behind. And if you guys see the camera, here's real bear. So for laser cutting, a lot of the time you're looking for the same thing. You're looking for 2-dimensional geometry. And most laser cutters are not the most sophisticated interface. And you're just going to set the speed of the laser and the power of the laser. And if you set a high speed and a low power, you're going to just etch the material. And if you set a high power and a low speed, you'll cut all the way through. And you kind of learn off different power and speed settings for different materials. And that's how you kind of operate a laser cutter. So you really just need two-dimensional curves, and you're either cutting the raster inside of the curve, kind of like a pocket cut on CNC, or you're cutting along the profile. And this is a really cool project where it's called There's No Place Like Home, because these shoes, they don't have a screen, but they have GPS built in. And on one shoe, they've got 4 LED lights in a line. And on the other shoe, they've got like 8 LED lights in a circle. And you tell the shoes beforehand where your home is, and you click your heels together, and it says 1 mile, 2 mile, 3 miles, or 4 miles, and in that direction, and sort of guides you home with this really low-tech interface. But I just love the laser cutting on the bottom of these little drawings, and they've just drawn the laser cut go. And here's an example of a laser cutter, and just need these as curves, and then set the cut speed and the speed and the power to cut through this material, and you're going to get a laser cutter. Also important with laser cutters or any of these machines is what the maximum dimensions are, because you're obviously going to need to make your files to fit within the machine's size. For 3D printing, there's lots of types of 3D printing. These are machines by Formlabs, which came out of MIT's Media Lab. And they use a process called inverted stereolithography, better known as SLA. And when they did this project on Kickstarter, they did, I can't remember exactly what it was, but it was a couple million. That the process was still under patent, and they had to wait 2 years at least before they could ship to backers, waiting for the patent to expire. But now they've done a second machine, a third machine, and are doing really, really well. Stereolithography is a very precise type of 3D printing, generally considered very expensive. Historically, these machines by Formlabs make it still not cheap, but a lot more affordable than it used to be. And this is a project that makes extensive use of Grasshopper by Arthur Manimani, who was my teacher of Grasshopper a decade ago when I first learned the software. And this is a 3D print done on a Formlabs printer, I think. And you can see how thin some of the profiles are. And hopefully you kind of don't know all the Grasshopper commands to make this, but you can kind of see the Grasshopper-like logic to how it's created. And with any 3D printing process, you're looking at what is the maximum dimensions of the print area, what is the layer thickness. And the more layers you have in 3D printing, the better resolution the 3D print is going to be, but the longer it's going to take to 3D print, because the machine is going to make a two-dimensional print of every single layer. And if you want quarter the thickness to be more accurate, that's 4 times the print time. And that's a decision one needs to make. Minimum wall thickness is really important when you're 3D modeling files to be 3D printed. That's the thinnest size that a solid object can be for this particular method. And the thinnest it can be changes depending on the method. And you're doing it with somebody who's 3D printing the things for you. They might be a little bit more conservative and want slightly thicker wall thicknesses, so the models definitely don't break. If you own your own machines, you can do a little bit more trial and error and see how thin you can get, and learn how to be kind of more of a craftsman of a 3D printer. This is an image from a MakerBot, and you can see just layer thickness is thicker on the right here, and they've done these cats thinner and thinner and thinner. So this cat would take probably 4 times the amount of time to print as this cat. Different processes have a different profile on the layers. So MakerBots are FDM, deposition modeling, where the first printer I showed you is an SLA printer. You can see the layers have this different profile, which this gives a much smoother edge. Another type of 3D printing is the Z-Corp machines, which are powder-based, and they work by, this is sort of a gypsum or plaster, and one of these drums is empty and one of it is full, and the printer will basically transfer the powder layer by layer from one to the other, and every time it prints a layer, it will also print a glue or binder. And when you do your 3D model, it's going to slice it up by the layer thickness, kind of like we did the contour command. And it's going to be 0.1 millimeter layers or really thin layers. And then that's going to be a layer of powder, a layer of glue, and go to the next layer and to the next layer. And then at the end, you're going to dig out the 3D model, kind of like an archaeologist, which is basically glued powder from non-glued powder. And what you pay for is the amount of powder you remove from the machine, and then as well as that, the amount of glue. So it's sort of a combo price. These are some examples of 3D models made with Z-Corp 3D prints. They generally have a thicker wall thickness and are kind of more fragile. If you kind of don't want too much glue, because if the more glue you put on these models, the stronger they will be, but it kind of gets a bit tacky looking. So you kind of want a happy medium. But if you don't put enough on, they kind of crumble. So they are shorter lifespan than a plastic model, which is just going to not, you're not going to have many problems long term with that. The powder, these are 3D prints, by the way. They don't really look it, but this is powder 3D printed with ink going in. So every time it does a layer of 3D print, it's going to have ink go in there as well. This is, again, a Z-Corp machine, now owned by Shapeways. And sometimes people do experimentation with 3D printing, and this is a cool project by Bowling Green State University, where they, so the Z-Corp machines are kind of like a Hewlett-Packard business model, where the ink is expensive. For the Z-Corp machines, the powder is expensive, and you're meant to buy the powder from them and not use any other third-party powder. So Bowling Green State wanted to just try any kind of powder it wanted, and did ceramics and glass, and just started pushing powders through and coming up with its own binders. And these were shrink tests of 3D prints from a ceramic material that they then fired in a kiln. And I think they got in trouble at first, and then Z-Corp asked to collaborate and sponsor them. So it's that kind of sort of break the rules and then get invited to the party afterwards. So, and they've sort of filing patents on, they also want to compress, every time it does a layer inside the machine, to then compress each layer, because that's better for if you want to do a cup. And then same kind of idea, powder plus binder. This is stone, which is crushed into a powder, and then on a massive 3D printer, built up layer by layer with a binder that sort of makes the stone part. And then you dig it out the same way. So when it comes to 3D printing in Rhino, this is a 50 millimeter by 50 millimeter box. If I 3D printed a solid box, that would 3D print fine, but it would be a lot of material. And in a Z-Corp machine, that would just be a solid box. So every single layer is going to be a square. An open box, which is each side of surfaces, I just exploded this box and deleted the top surface. That won't print at all, because, as I said, surfaces have no thickness whatsoever. So this is a thickness of 0, and it will just appear invisible to a 3D printer. If I do an offset surface, I give it a thickness. So I've given it a 1.5 millimeter thickness using offset surface. And I just did Rhino's, if you type volume, and you'll get the volume on shape. This is 14% the volume of this cube, which means it's 14% of the price. And that could be $25 versus $250, and it's going to look the same no matter what. So if you turn it upside down, then it will look the same. So if we go back to this slide here, if this was an offset surface with nothing underneath, it would be 14% the price of if I just made that solid. So a very important command with Rhino, especially to check your precision, is show edges and then do the naked edges. And naked edges are just any surface edge that is not part of a solid. So in this case, all of these are exploded surfaces. They're not connected, and therefore all of these are naked edges, where all the edges on the other two cubes are part of a solid poly surface. And if I was to explode the box and redraw the top square where I'm deliberately off by 1 millimeter, that if the surfaces are not joined, so these are all separate surfaces, and I do the show edges, naked edges analysis, that I'll get pink edges on all the edges. But if I join them, I just get pink edges on this open part here. And that's very important because that box currently would not 3D print because it is an open poly surface and only closed solid poly surfaces will print. So you kind of, depending on how you create a geometry, but if there's any risk that there is any imprecise parts, you want to do this test of show edges, naked edges before any 3D print. Especially sometimes that if there are a bunch of parts that are stacked on each other, and let's say there's 5 parts, the middle part is got a problem and there's a little hole in it, then they will just 3D print without that object in the model, and you'll have where it was meant to be one piece, you now have 2 separate parts because the middle part was just invisible. This is super advanced, but back to Adam Holloway, who I showed you that colorful minimal surface, and Arthur, who did the Burning Man Temple project, and Carl, they created this plugin for Grasshopper that changed how you do 3D printing. It's a very difficult to understand plugin, but it's normally 3D printing is done in horizontal layers called slicing, and a 3D printer needs to go through that whole horizontal layer before it moves up and does the next horizontal layer. In this model, they've sort of gone directly to the G code, the underlying code of 3D printing, and said that you can just move the 3D printer, turn the extruder on, and then move up vertically to create this kind of twirl piece. And in this side, that to create that geometry, that's not going to work by horizontal layers. It's going to need to sort of move up and down and up and down and up and down to sort of create this weaving effect, which is quite an interesting hack on 3D printing. So setting materials, which I'm going to show you when we open the software, that materials are properties for any object or surface or polysurface. And there are a lot of preset materials that are included. So you can just select plastic, wood, and there's a ton of ranges of wood, or paint, and then select a color. And then you can alter the settings for transparency if you want it for glass, or glossiness, which would be turned up to max for metals, and change around with the settings that way. Separately, there are textures, which are image files that you scale and you bring into the material. So this is wood, which has the texture included in that. We're not going to cover much on setting materials and rendering because it's like a whole course in itself. Then lighting, we can turn on. I'll show you lights when we open Rhino, which then shadows will appear in your render view, which normally there wouldn't be shadows. And you can set environment settings, set what location this model is in the world, what day it is, what time it is, and the shadows will sort of match that sort of timing. And then there's just multiple lights with multiple shadows. The lens length in perspective view can be altered. So this is a 10mm lens, which when I did that Harlem Run t-shirt, I had a very small lens length, which from the top, which created that sort of geometry. And if the lens length is very large, that you get this more flat sort of 3D. You can also go to isometric, which has no perspective points, and change your view, and then do make 2D on any of these views to capture that 2D geometry. And now I'm going to start drawing soon with the final project. So the final project, which I hope you guys can all create and get your certificate when you submit, is to do either a furniture piece or some object maybe related to things you're interested in that has something from each week that we learned. So it has something from NURBS curves, something from maybe solid geometry, something that's subdivision based, something that's Grasshopper based, and then maybe set a material and do a make 2D or have the files ready to CNC. So you've kind of done something from each of the 5 weeks. And I'm going to show you an example of something that meets that criteria. And it's going to be a sort of refresher on the creating geometry in each of the different types. So as one just type of geometry that was very popular in the 90s, and I still think is really, really cool, is a Voronoi, and that's where you just get a bunch of points, and this is just a randomly organized set of points. And if those points find their nearest points and create curves between all their nearest points, and then you will find the perpendicular bisectors of the midpoints of all those curves, and then trim them all, and then delete the purple lines, that we get this sort of shell pattern. And let's turn off the lights. So this is a Voronoi pattern, and it's controlled by those underlying points. And I'm going to do use a Voronoi pattern, which is just a ready-to-go Grasshopper component. But when people were doing this for the first time in the 90s, there wasn't a Grasshopper, and this was coded from scratch. So in this case, this is a Voronoi pattern, and then an offset from every one of the cells, and then rebuilds the curve from a first-degree curve to a third-degree curve, creating this NURBS curve in the middle, and then a planar surface between those two, and slightly creates these triangles of various Voronoi patterns as well, and then sends that to a laser cutter and makes this as a full wall in the architecture school at Columbus, Ohio, OSU. And one of the tools I'm going to sort of indicative use in my design is a bullnose router bit. So in controlling any router bits from Rhino, I'm just going to have profile curves, and when you export it, you would sort of assign this router bit to go along that curve. So I just really need the mid curves. This is an example of using a router bit like that there. And this is kind of what I'm going to draw. So I'm going to draw this in Grasshopper. So we switch to Grasshopper. Switch to Rhino and Grasshopper. So the first thing I'm going to do is start with NURBS curves and draw a rectangle with, let's say, 250. So I'm going to create the legs first using curves. And I'm going to snap to the midpoint. My snaps are on. And I want a circle exactly that length. And that will snap to that point, and I'll just drag that down. I'm going to use the trim command and trim those sides and that side. And then I'll just explode this curve and delete this bottom leg. And then I'm going to join that together and offset it, let's say 15 mil each side. And I'll just take any point, doesn't matter, on the side. And just move these 2 points up, let's say 50 mil. And there will be a seat here. So I'm gonna, let's say, I'm just drawing one of the tool sides, and then I'm going to use a mirror command to bring them over the other side. So now I'm just selecting this and trimming various curves. Add some curves to the bottom. And I'm going to join that to make one curve. And I'm just going to join that one and then type close curve, which will fix the other one. So there's kind of a stool leg made out of NURBS curves. And I made a lot of CNC furniture. I kind of know my way around. I'm going to basically offset this. I'm offsetting that 9mm each side, creating an 18mm gap here, and then copy this to make a second one. Again, just trim more sides. Delete those, and then midpoint to the midpoint. And then I'm going to trim top side on one and the bottom side on the other, and they will lock together when CNC. So join all those so they're piece. And I'm just going to move this corner to my origin point, since I like everything to be the origin point. And just so I need them for 3D is extrude, curve, and both sides needs to be off an 18mm, which is this thickness of my plywood. And then if I just select the extrusions, which are closed poly surfaces, and drag them away from that. 600. I can do rotate 3D. And then rotate this one 90 degrees. And then I'm going to move them and snap to points. So if I was just to CNC these curves and do a profile cut on the outside of those curves, I would get from CNC that geometry there in 3D. And now I'm going to create a top using Grasshopper and subdivision. So I want a circular top, and I want it to be snaps. So it should be 280, so it's a radius of 140. Yeah. I'll that up out of the way. And Voronoi are quite interesting when you kind of really, if you mess around with different underlying shapes, you realize how drawing nature, you just use different curves, and it creates this very biogeometry. So I'm going to use a spiral, and I want the spiral to be flat. If I didn't type flat here or didn't click flat, it would be a three-dimensional spiral. Snap to the center point. The edge of the spiral is going to be the edge of the seat, and its default is set to 10 turns. If I wanted to increase the turns, I could increase it there. That's fine. And I could do that in Grasshopper if I wanted to do more in Grasshopper, but I'll just do a little bit in Grasshopper. So I'm going to open my Grasshopper window, which currently has nothing in it. And I want to bring that curve in. So I type curve and take this basic curve with, it's just going to ask me to set one curve. And I want to set the spiral. And I want to divide the spiral. And so that's going to create a division point. And currently the number is 10, but I want to make that a slider. And set the slider to integers and change the limits from a minimum of 1 and let's say a maximum of 1,000. And plug that into the number of divisions. So now our spiral, if I move this, no, it didn't save it. And commit. Here we go. So I get 1,000, up to 1,000 division points on that spiral. And I want to do a Voronoi, which I can just type Voronoi. And I want those division points, where the example I showed you on the PDF was randomly assigned points, but I want those points to be and then I want to bring in another curve, and this time I want to bring in the circle from the edge. And I'm going to set the circle for the edge as the boundary of the Voronoi, so it doesn't go out like the rising sun here. So now my Voronoi is at the boundary point. Just so I can see what's going on, I want to turn off the preview of the points. I'm going to hide the sort of edge circle. I'm going to hide the spiral. And I might do this in the top view so I can see it better. Okay. So as I move this division points now, that's basically dividing our spiral and automatically creating a Voronoi of the points that it creates. So I could even turn off the spiral. That's that one there. Okay, so what should I do? Let's do it about there. And then I'm going to bake that geometry. So I'll put on a different layer. That's on layer 1. And now I'm essentially done with Grasshopper. And so when I have my layers open, I can actually right click on layer 1 and select objects. And that's just a nice way of selecting just what's on that layer. And I'll drag this over 100. That way. Clearly I didn't rotate that properly. I must fix that later. So it does 90 degrees. And I want to show, because I want this edge circle to go with it, and I moved it exactly 400. It's good to move things by precise dimensions so that if you forget something, you can just move, copy 400 millimeter from that side. So each one of these cells is a closed curve. If you remember the multi-pipe from the kettle exercise, I'm going to do a multi-pipe on all of these curves, but I don't want, I want basically one curve in each position, where currently in this one position is this cell and this cell. So I can explode and select all this geometry. I don't need the circle, and I can explode it all. And that you can read from up here, it exploded 142 curves, which were the closed cells, into 823 segments, which are just individual curves. I want to click off, and I can type select duplicate or select DUP, which is quite useful in numerous situations. And it's selected 396 duplicates, and I can just delete. So now when I click on each of these, it's just one curve in each one of these positions. So then I want to use the circle to trim these outer parts. And I guess if I wanted to spend the time, I could do the whole thing in Grasshopper, but I'm just doing a little bit in Grasshopper based on what we already know. Could probably get away without being so accurate, but I'm just going to take the time to delete all this geometry. All right, that's close enough. And so now I can select all these curves, and probably best I do this in perspective view. I'm going to do a multi-pipe on the whole thing. So multi-pipe, I'm going to do a pipe radius of, let's try 3, cap ends off, and 1 is fine, and there we go. So there's some mistakes there. So I'm going to extrude my circle by the thickness of plywood that I'm going to use 1/4 inch, which would be 18 millimeter. And let's copy that once. And my subdivision has messed up slightly, but let's try it again. So I'm going to do a bounding box on the curve and a bounding box on that. So I can drag this subdivision across. Accurate. So I want to snap to that point and then the top point of this bounding box. And now I'm going to use solid geometry to Boolean separate that subdivision geometry. So I'm just going to do Boolean split. And I just did tab on to turn this move on. And hopefully this will separate. But from controlling a CNC machine perspective, we actually just need these curves and then to assign a ball nose router bit, which is the one I showed you at the end of the slideshow, to those curves, and then it will move on the line, profile cut these curves, and this would be the end result. So for CNC machining, we actually just need the curves. And it's going to take a bit to build in. And that's most of it done as far as modeling goes. I'm going to then set some materials and make 2D works very well with simple geometry. Sometimes it kind of gets a bit messed up with more complex geometry and needs to be tidied up. There are a lot of subsettings that weren't there in previous versions, so it might be better in Rhino 7. This might be better on a faster computer, but my laptop's a little slow. If anyone has any questions, I can just delete this top part. There is my Boolean.geometry. So my hope is to create that as a stool top, and it's got enough points on the stool that should still be comfortable. And we can move this to the top. So before I made sure that this is not perfectly straight. So let me so now that's better. And I can snap to and then I'm just creating bounding boxes so I can snap from one to the other. And then I want to move that down. I can't remember what I said it was. It's like 6 millimeter. So that's our stool. When creating the CNC file, we would need to pocket cut the parts underneath for these, which one way of creating that geometry is to just Boolean out from this, and it'll be, I don't know if it will slow down my computer again, but
James, do you do everything line to line for your CNC work, or do you leave a little bit of gap, a little bit of tolerance or clearance in those?
I'd leave a little bit of clearance.
How much?
Huh?
How much would you leave?
Depends. I mean, I usually like a millimeter.
Okay.
Oh, sorry. Do you mean on, sorry, vertically a millimeter, definitely not on the other side. It takes a lot of, I mean, wood obviously, plywood can expand depending on the season, and it's kind of a trial and error process. Sometimes the CNC, especially since I use a shopbot, is some of the machines are more accurate. Sometimes they're a little off, so you kind of, I do like a few tests and then see how that goes, and then apply that tolerance to the rest of the geometry and then recut. I wouldn't sort of take a file and cut it directly without doing a tolerance check.
Okay. Makes sense.
And I guess when I first did it, I just made like 15 different slots and like made it in wood, and then with the wood put it in each of the 15 slots and check which fit I liked the best, and
Yeah,
I guess did it in the real world for trial and error, and just this one works the best.
that's cool. Thanks.
So just as a last step in the last few minutes we have, if I just grab this and let this be up here in the corner. So this is properties that we've done before, layers, rendering, and then the fourth one is materials. If we add a new material and kind of see these set materials already here, I don't think they have wood, so I need to just go, they're still in the downloaded file, but they have lots of more options here, so I can select wood. They have all these types of wood. I want birch, but I don't want polished birch. And that adds to my material file. And then there's a few different ways I can do it. I can select all the geometry, right click on the material and go assign to objects, or I can just drag it across. And in ghosted view, I'm not going to have a material, but if I bring it into rendered view, there we go. So there is a object that uses some subdivision geometry through the multi-pipe tool, some grasshopper geometry through Voronoi, and on a spiral divided points, some NURBS curves for the legs, and then kind of sets it up, which I guess I haven't totally finished, but sets it up for a CNC file. And we could do make 2D on this. And hopefully in your final project file, you're doing something from each week. Hopefully that makes sense. And then there should be a place to upload your file, which I'll send info. I'm not sure exactly where we're doing it, but you can send your .3dm file, or we might just do an image. I'll let you know. And maybe just describe some of your steps. There's a Google spreadsheet actually, or Google quiz that I created already. And you just take a checkbox and say, my model has NURBS, my model has Grasshopper, and that kind of thing. So that's kind of the conclusion to the course. Hopefully everyone, if they wanted, could create this stool and or lots of other cool projects. And if there's any questions now, I'm going to stay around. And if you have any questions in the following days, I'll be happy to answer them on the Hackaday page.